Welcome back. We are about to complete one of the most epic problems I have ever had to solve when I took physics. As we will see together, this is a problem that's going to combine forces, and it's also going to combine kinematics, which is why I think this is an excellent type of test question you can get because it combines concepts from multiple chapters. All right, so with that said, let's get right to it because I've clearly hyped up this problem. So let's prove how brilliant it is. So what we have, it's actually pretty simple. We have a pulley system. So that pulley has two things hanging on it. There's two objects, and the objects are 1.8 meters above the ground. This is a slightly lighter object. This is 3.2 kilograms. This is 2.2 kilograms. And it says after the system is released, which means once we kind of like let go, right? What's going to happen after the system is released? This is going to go up, and this is going to go down because this is clearly the heavier object. So they don't actually even tell you this in the problem, but you can kind of make that assumption that this is going to go up and this is going to go down. So after the system is released, what is the maximum height that the lighter object reaches? Okay. Now, when I first saw this problem, I was like, what is the maximum height that the lighter object reaches? Well, I said, well, this object is going to go 1.8 meters down, and this is clearly going to go, by default, 1.8 meters up. So I thought that that's your answer, that the maximum height that the lighter object reaches is 1.8 meters, which I was slightly naive to assume because that is true, that when this goes 1.8 meters down, this is going to go 1.8 meters up. But that's if it was that easy, then this problem wouldn't be written, right? So there's clearly something going on. So what's actually happening is when this heavier object hits the ground, that's going to kind of, so when this is at the ground, and then that means the 2.2 kilogram object is up here, this is going to kind of hit the ground with a thump, right? So it's going to create a little bit of force. When it hits the ground, it's going to create a little bit of thump, which is going to cause the 2.2 kilogram object to go a little bit higher than that value right here. So if it went up 1.8 meters, then this really heavy object is going to hit the ground, which is going to cause this lighter object that was here to just bump a little bit higher, and that'll be its maximum height. So really, I mean, the maximum height is going to be around 1.8 plus 1.8, but it's going to go slightly higher because this really heavy object is going to hit the ground with this thump. That's going to create a little bit of extra force to just kind of push that out. So I do think this is kind of one of those problems you'd really have to just see beforehand because that would be hard to reason all that for the first time. But once you see that, once it's kind of explained to you, then it makes more sense. Okay, so with that said, with that conceptual framework in mind, the first step is going to be to draw all the forces. So we have two objects, so we need to draw all the forces on both of our objects. So on this object, what are my forces? Well, I have gravity is pushing down, and tension is pulling up. On the right side, for the heavier object, you have the same situation. Gravity is pulling down, and tension is pulling up. There's no normal forces and no friction forces because there's no contact with any surface. So that's nice. And this is your first box, which is on the left, and then your second box, which is on the right. So what are all the second step is anything two-dimensional break down into x and y. None of these are two-dimensional, right? They're all in the y direction, both of them. So that's nice. The next step is to add up all your forces in the x and y direction. Luckily for us, there are no forces in the x for both of them. That kind of reduces our workload. In the y direction, you have a tension going up minus the force due to gravity. I'm sorry. We're going to add it because this is going to give you an intrinsically negative value. And that's going to equal ma, because your net force, you do have a net force in the y direction. Okay? Now, so if you haven't seen the previous videos, when anytime something's going up, in physics, that means it's positive, and anytime something's going down, that means we give it a negative value. So if this should be a negative value, why did I add it, right? That's kind of the confusion that a lot of people have. And the reason I added is because I know kind of ahead of time that the force due to gravity is going to give me a negative. The formula for force due to gravity is the mass of the object times the acceleration due to gravity, which is negative 9.8. Okay, now and since this gives me an intrinsically negative value, I can just go ahead and add this because I know I'm adding a negative value by default. So that's why I'm adding, because at the end of the day, it is going to give me a negative value. So I have tension minus the mass, which is, let's just plug that in, 2.2 times 9.8. 2.2 times 9.8 equals the mass, which is again 2.2 times your acceleration. Okay, cool. And in the y side, again, I have tension going up. Gravity is going down, but I'm going to add it because I know eventually I'm going to get a negative value. So as long as it's negative at the end of the day, that's what we care about. And this is going to equal your mass times, acceleration. Oh, and I forgot to do one very, very important thing, which I actually warned about to always do in the last video. So maybe we should have made a big note in the beginning. Anytime you have two objects, you always want to check, are the accelerations going to be the same or are they going to be different? Okay, so big theme in physics. So theme. Whenever you have two objects, check if your accelerations are the same or different. Whoops. Okay. Check if the accelerations are same or different. So what about here? Are the accelerations going to be the same for both of these objects, or are they going to be different? Well, they're both attached by a string, right? So you know that the magnitude is going to be the same, because if this one is falling really, really quickly, then this one has to go up really, really quickly because they're both attached by the same string. But since this is going up, that's going to be a positive value, and since this is going down, it's going to be a negative value. So by default, actually, they're actually different. So A1 equal, actually, before I'm getting ahead of myself. So they are different. This is A1 and this is A2. Even though the value is the same, right? Let's say acceleration is 10. So this would be positive 10 and this would be negative 10. So the value is same, 10, but since this is positive and this is negative, they're different, right? Because positive 10 is different than negative 10. So they are different, but we just said they're really, if you think about it, they're really the same. The only difference is the sign, right? So whatever A2 is, if it's a positive number, then A1 is going to be negative, and if it's a negative number, then A1 will be positive. They're the same exact value, just the sign is different. So they're different, but now we're going to kind of substitute this in here so that we're kind of back on the same page. And you want to do this kind of right away, because you don't want these extra variables, A1 and A2. So we say they're different, but then we're going to substitute this in, and we're going to get m times negative A1, so that we're kind of back to this one variable, and we don't add this extra variable unnecessarily. Okay, and let me just rewrite all this. So you have tension. And what is the force due to gravity? The force due to gravity is the mass. What is the mass? It's 3.2 times, 3.2 times negative 9.8. So notice it is a negative value. That's why I'm okay with adding it, because at the end of the day, it's negative, and I am actually subtracting it from the overall, from that tension force. So all of that is going to equal mass times negative A1. So I have two equations and two unknowns, right? Here's my two equations, and my unknowns are tension and A1, tension and A1. So if I solve for, let's just solve for tension. So I can say tension here equals, and if you plug this into your calculator, you're going to get, this is 22 plus 2.2 A1. And then you can take this tension here, plug it in there, and if you solve for all of that, you'll have one variable. And if you solve for A1, let me see my calculator. I have it in my calculator already to save us time. You'll get that A1 equals 1.8 meters per second squared. And does that make sense that it's a positive value? Yes, because we know that we are going up and it should be positive because anything going up is positive. Cool. So we have our acceleration. Now, the goal is to figure out the maximum height, right? So you might be thinking, what was all this work for? But like I said, it might not even seem too obvious why to do all this, but clearly forces are acting on this object. So in general, whenever a force is acting, even if you have no idea how to figure out this maximum height, show as much as you know, right? You know that all these forces are acting on the object, and we generally need to figure out net forces. So it's a good idea to do this anyways. And now I'm going to show you kind of how we can take this one step further. So the problem is asking, what is our maximum height? Okay? So if we look at the previous force problems, right, what were they asking? They generally ask, what is the acceleration? That's a very common thing to ask, and we've solved that here. So we got the acceleration. Or they'll ask you another force. They'll say, tell me the tension force, or tell me the normal force, or whatever. But notice, they are always asking about acceleration and forces, right, which are just forces. This is asking you for height. And what is height? Well, height is a way to describe motion, right? If we go back to kinematics, what were the 6 ways to describe motion? You can talk about acceleration, v initial, v final, x initial, x final, and time. So your height would fall into the displacement category, the x initial and x final. Actually, we're talking about height, so that'd be y initial and y final. So whenever you see the word height and they're asking for it, that should be a trigger to you to think, aha, I need to do kinematics eventually, right? Maybe you have to do it right away, but if it doesn't seem like a kinematics problem offhand, but they're asking for something that describes motion, then you have to make that jump. You have to be like, this kind of looks like a forces problem, and yet they're asking for something kinematics related, so maybe I have to do both. And that's exactly why I think this is such an epic problem, because it's combining both of them. So let's do that. So let's do kinematics. And what's my rule for kinematics? My rule for kinematics is, no matter what the problem is asking, and if you have no idea what's going on, you always look for 6 variables. So acceleration, v initial, v final, y initial, y final, and time. These are your 6 ways to describe motion, right? Because how do you describe someone's motion? You can talk about their displacement, you can talk about their velocity, you can talk about their acceleration, you can talk about their time. There's really only 6 ways to do that. And this object is only moving in the y direction. So that's why this is actually a one-dimensional kinematics problem, because it's all happening in the y direction. So this is all in the y. So whenever you do kinematics, you write these 6 things, you plug in what you know, and you put question marks next to what you don't know. So do we know the acceleration in the y direction? Do we know the acceleration in the y direction? Well, we do, right? And normally, what is the acceleration in the y direction? So far in every kinematics problem, the acceleration in the y direction has always been gravity, right? I've always said gravity pushes down at a rate of negative 9.8 meters per second squared. But in this case, gravity is not the only force causing this object to accelerate. Gravity is causing to accelerate down, but since that tension was pulling it up, that's going to influence the overall acceleration of this object. So that leaves us kind of puzzled. What is that overall acceleration of this object? Well, we just figured it out, right? That's why we did all this work. We literally did all of this work right here, so we could plug in 1.8 over here. So that's why the acceleration is actually not negative 9.8, but it's actually positive 1.8 because yes, gravity is pulling down, but the string is pulling up a little bit more. That's why your net acceleration is 1.8. Great. So we're describing the motion of this object. So we're describing it as it's going there. So that's 1.8. What's the initial velocity? Well, we can assume it's starting at rest, right? Because it says after the system's release, what's going on. So before, that means it's starting at rest. What is v final? We don't know, right? What's it going to be its final velocity once it reaches that point up here? We don't know. The initial height is 1.8 meters above the ground. So that's 1.8. And then we know it's going to go 1.8 meters up at least, right? So what we're actually doing is, let me be even more specific in case this is confusing you. What we're doing right now is we're actually describing the motion. So remember when we did kinematics problems, right? And you're describing the motion of an object, I said you could break up that motion into multiple parts. So what's going on with this object? It's going up 1.8 meters until it hits this point. Then this really heavy box is going to hit the ground, and that's going to cause it to accelerate a little. It's going to go up a little bit more, right? So what did I say? I said you don't have to look at the entire motion. You can split it into different parts when you're doing kinematics. You don't have to just look at what is from beginning to end. You can say what's beginning to this point, and then let's look from this middle point up to this end point. So really, this kinematics that I'm doing here is from the beginning. So this is kinematics from beginning to this point here, which I don't even know what to call it, to when this box hits the ground, and then this goes up 1.8. So I'm going to say when you've gone up 1.8 meters, I guess. So beginning to, or let's just say middle, even though it's not like technically the middle, but you're somewhere in the middle, right? So this is kind of the beginning to this middle point here. That's what I'm describing the motion for. Okay, so I'm sorry if that's a little bit confusing. I should have clarified that earlier. So if we're only going to this point up here, then that means we're going, what's our y final? Sorry, y final is 3.6, right? 3.6, because if we're falling 1.8 meters here, that means we're going to go up 1.8, and if we're going up 1.8, 1.8 plus 1.8 gets you 3.6. And your time is unknown. So what are we trying to solve for? Well, remember, and this goes way back to those kinematics videos, that if you are dividing your motion into two parts, so I'm saying this is part 1 and this is part 2. So right now we're just doing part 1 motion. When you divide it into two parts, your final velocity of part 1 will become your initial velocity for part 2, right? So if that confuses you, check out the kinematics videos from before. But the idea is that when this object is going up, it's going to reach a certain velocity at this point, right? Which is kind of the final velocity in path 1. But then when path 2 starts, that is the initial velocity. So this is that theme that is appearing again, that the final velocity in your first part is becoming your initial velocity in your second part. So let's solve for final velocity, because then we can do the second part. So what is the final velocity? Well, we're not given time. So anytime you're not given time, you know you want to use this equation. V final squared minus V initial squared equals 2a delta y. You want to use this equation because look, there is no time anywhere. So it's a great equation when you're not given time and you need to figure out other things. This is your go-to equation. So V final squared minus 0 equals 2 times 1.8 times delta y, which is final minus initial, 3.6 minus 1.8, so that's also 1.8. When you solve all this, and you'll plug it into your calculator, you'll get v final is, so you'll get plus or minus 2.56, right? Because anytime you take the square root of something, so we have v final squared equals this, we're going to take the square root, you get plus or minus. So which one is it? Is it plus or is it minus? Well, we're going up, right? We're going up this whole time, so the final velocity is pointing upward, so it is positive 2.56 meters per second. That's your v final of part 1. Now, when that means at this point right here, my velocity is 2.56. And that's exactly when this heavy object hits the ground and pushes it a little bit further up. So guess what? We have to do kinematics again from that middle point, all the way to the end. So this is kind of our part 2, from the middle point here all the way to the end, which is only going to be just a little bit more. So again, we have to do the same thing. Acceleration, v initial, v final, y initial, y final, and time. And this is all one-dimensional. It's all happening in the y direction, so we don't have to look at the x side. Thank God, right? That'd be quite a long problem. So what's the acceleration now? Well, now, right, once this heavy object hits the ground, and this lighter object is up here, and it's just going to kind of jump up a little bit more. Even though it's connected to this pulley, right, it's not, what's going to be its acceleration? It's just going to kind of jump up a little bit more, so its acceleration is going to be entirely influenced by gravity. And that's kind of tricky, because you think, well, isn't it connected to the pulley, so how come the acceleration is not 1.8? Well, you're right, it is connected to the pulley, but the pulley system is kind of ended, right? This has fallen down. This lighter object is now up here, and then it kind of just bounces a little bit more. So even though a string is attached to it, that string is not exerting any force on it. It's just kind of attached there. This is just going to kind of bounce a little bit more up and then fall back down. So when it bounces up like that, the only force exerting on that object is gravity. And gravity causes an acceleration at negative 9.8. So I hope that made sense. Let me just reiterate it one more time if it didn't. When this lighter object is going up, okay, clearly the string is pulling it up. It's obvious that this string is influenced in pulling it up. So that's why the acceleration is a combination of, the force of tension and gravity. But once this kind of hits rock bottom and you're here, it's going to push up a little bit more, but and even though the string is still attached to it, the string really isn't pulling it up anymore. So therefore, the acceleration is solely due to gravity, which is negative 9.8. All right, what is your initial velocity? It's this velocity right here, right, at this point, which we just figured out is 2.56. Your final velocity is 0. Because anytime you reach the peak of your projectile motion, right? Whenever you're doing kinematics, and whenever you reach the peak, you have a final velocity of 0 in the y direction. So this goes back to kinematics problems when we throw a ball in the air and then it kind of falls down again. At its peak, right, it's 0, because if it has to reach a 0 velocity, otherwise it would keep going up forever and ever. So since it's 0, then it falls down. Your y initial is 3.6, your y final is unknown, and then your time is unknown. So to figure out this, how do we figure out our y final, our delta y? Well, again, we're not given time. So if we're not given time, our go-to is this equation right here. So I'm going to now use this equation, but I'm going to now plug in these numbers instead. So what's v final squared? Well, v final is 0. 0 squared, which is just 0. So 0 minus 2.56 squared equals 2 times negative 9.8 times delta y, which is y final, minus y initial, which is 3.6. So I apologize, this is slightly messy, but if you if you see, we're left with just y final. And if I plug that in to my calculator, I will get that y final equals, and let me check my calculator, y final equals 3.93 meters. So that is your final answer. Your maximum height is 3.93 meters. So brilliant problem, because it involves forces, it involves kinematics, and not only easy kinematics. This was like hard kinematics where you had to split it into two parts, right? A part 1 and a part 2. And if that confused you, check out the kinematics videos where I explain how you can do that easily. All right.